So if I had only 2 words to sum up how we think about security in Google Cloud, it's this. It would be trust nothing. So as you start moving your services to Google Cloud, the first thing you do is obviously secure your VPC. You'd secure connectivity to your VPC. You'd apply really granular policies with IAM, Kubernetes engine, network policies, and more. And one of the most important things that you would do after this is to secure your internet-facing apps. Now, this is actually a tough job because you do need to serve your users fast, but then at the same time, you need to block out DDoS and application attacks. And this will be the focus of our talk today. So how can you defend your services against protocol, volumetric, and then application DDoS attacks? So this is what it looks like. Now, this is actually a graph that is drawn based on the DDoS attacks on Google's own services, so services such as Search and YouTube and Gmail. And of course, our security experts work round the clock to protect Google's own services from these attacks. And as you can see, the attacks are growing exponentially in volume, and not just in this respect, but also in respect to packets per second or any of the other parameters. And you can notice that the scale is already past 1.7 Tbps. So one of the things I did was to ask our DDoS defense lead, like, what does absorbing a huge DDoS attack feel like? And he says, absorbing a large DDoS attack, it requires the bandwidth needed to watch 500,000 YouTube videos, all at the same time in high definition. So that's what it feels like. Now, if you look at this, these are all of the Google services and partner solutions that you have at your disposal to go defend against all of these attacks. The only one I'm not going to cover in this talk is the last one, which is Project Shield. But that is actually our free service that uses Google's technology to protect news sites and then freedom of expression from DDoS and other attacks. So the first best practice that we recommend for your internet-facing services is to start with a global load balancer and with TLS everywhere. So wherever possible, use TLS. And then as it relates to the load balancer, you would use either our HTTPS load balancer, or if your traffic is non-HTTP, so let's say you're running SMTP, then you would actually run the SSL proxy load balancer. And both of these are, again, global load balancing flavors, which means you can put your backends in any region you want, and you can front them with a single VIP, which gives you also a single point to apply all of your policies. We also have several features, including SSL policies. So you can restrict, for instance, specific ciphers, or you can restrict certain TLS versions, and this is especially important for PCI compliance. So we put in our global HTTPS load balancer. We put in our policies. The next thing that you would want to layer in is Claude Armour. Now, this is a new service that we introduced recently. And if you think of what it provides, you obviously need the table stakes L3 and L4 DDoS defense, which is actually really hard to defend against. In addition to that, you need something that's very extensible, where you can express what your intent is. So that is why there's a policy framework and a rules language. And then you have your features, such as blacklist, whitelist, or maybe you want to control access based on geo. And then you have your WAF protection, and with all of this, you obviously want to know what's going on, so there's the telemetry aspect of it. And with all of this, then you can also layer in a product that we call Identity-Aware Proxy. So this is based on Beyond Corp, which is how identity is handled inside Google. And then if you layer all of these three together, one of the other things that you would do is you have your VPC, or you have your instances in your VPC, and you would configure the firewalls on those instances to only allow traffic through the load balancer, because you put all of these knobs at the load balancer, and you want to ensure that no other internet-facing traffic actually leaks to your backends. So let's talk a little bit about Claude Armour. The first thing, as I mentioned, is that it gives you a policy framework. What you can see here is a snip of our gCloud console and Google console, and then you can see the three policies that exist in there. If you start zooming in on these policies, the first thing is you can apply a Claude Armour policy for a given backend service. So let's say we've got 4 services. Maybe these are your 4 internet-facing services. you could choose to reuse this policy. Let's say you defined a policy called Claude Armour Policy P1. You could choose to use it for web service 1. You defined a policy P2 and you used it for your service 2. And then you define a policy P3, but maybe it's applicable to multiple services, so you can reuse the same policy for multiple services as you can see in there. If you look closely at any of those policies, what you would notice is that a policy comprised of a hierarchy of rules, and then within each rules, you have something that you match the traffic against, and then there's an action that you take based on whether there's a match or not. So the actions could be allow the traffic, deny the traffic. We also have an interesting option called preview, and what that does is lets you test out rules. So if you configure the preview option there, it would simply log the action but actually not take it on your traffic. So if you're testing out the rules, that's probably what you would start with to begin with. Now, when we started talking about building out, almost a way to go express the rules, we thought about using a variety of different tools. Some were proprietary, but then we decided to use something that's not just flexible but also open. And we settled on CEL, which is short for Common Expression Language. If any of you have used Firebase, you've already used CEL. So that is what it's used for, expressing certain expressions. And then once you specify the rules using this language, Claude Armour will then use these rules to go orchestrate the underlying global infrastructure. And then obviously that infrastructure is going to allow or block your service based on whatever it is you've configured for the rule. So what are the types of things that you can actually do with Claude Armour? The first thing that you can do is you can either allow or block traffic for IPs or CIDRs. And this could be either IPv4 addresses or CIDRs or IPv6 as well. So we support both. If you think of the other types of things that you might want to do, a very common ask is for customers to be able to control based on the geolocation. So that is what you see in here. And you can combine it with IP addresses using operators like and or not. One of the other popular thing is how do we defend ourselves against all of these application attacks? And so that is what you see with the cross-site scripting and the SQL injection defense. This is where, again, you can see the rules language in action. So there's a custom rule that's crafted where it's looking for US, and then it's looking for certain things in the user agent, and then it's looking for a certain type of cookie. And then you could choose to do either deny or permit along with this one. And then the last important thing is once your traffic is allowed or blocked, it would go log this in Stackdriver, and then it would tell you which is the policy that it matched, which is the rule. So the priority is actually the rule number, and then what was the action that was taken. So once you have all of this in place, it is very easy to allow or block traffic based on your unique requirements. So I wanted to actually give you a quick look at what's under the hood. And so this one, the first one is actually pretty straightforward, where essentially for the L3, L4, you would turn on the global DDoS defense. In here, let's turn on this defense, because what I want to show you is actually what's coming next. The second thing is let's go and launch an SQL injection attack, or SQL injection, as some of you call it. And in here, it's actually worse than just bringing your service down, because it would actually go and also try to steal your data. So I wanted to just walk you through the back end of this to show you what it looks like, which is let's go in here. This is the actual UI here. You would go to this tab called Network Security, and then you can see that we have a bunch of different policies. So these could have been just rules in a policy, or they can be different policies itself. Let's look at the one for SQL injection. Now, if you see in here, the most important one is the one you see in here, which is evaluate pre-configured expression. So you just need one rule, and then under the hood, it's going to look for 160 patterns to actually go and then block the traffic of SQL injection. The other policy that I wanted to show you is the one that I showed you briefly on screen, which is this one. And then if you see in here, the first rule, so let's go and try and edit that. So if you look at this rule, and I will see if I can zoom in so you can see it better. So when we start looking at our rules, we have two modes. One of them is essentially a basic mode, which is the one you see on top. And that's simply if you want to add a blacklist or a whitelist. What is most important is actually this advanced mode, which is what you see here. And then the entire rules language that you see actually can be used here. So this was the specific example where you would look for traffic which is from US, and then where the user agent contains bad bot, and then the request headers, the cookie itself contains the specific value that you see in there. Some of the other things I wanted to point out is, as I mentioned, there was an allow. If you do a deny, you can also look through several of these and then figure out what is the status code that you want. And then the preview mode, you can simply enable here, and then the priority would tell its order or its place inside the hierarchy. So you can see that on the right here. So that was basically a look at what the policies look like. And then switching back to Claude Armour and then some of the things that we do with it, one of the most interesting things that you can actually do with Claude Armour is to combine it with several of Google's technologies, and also combine it with several of our partner solutions. So while we won't have enough time to go through solutions from each of these partners, you can see that it ranges from identity and access management to scanning to governance, compliance. Even we have like, CASBs, we've got things against phishing and so on. So on our website, we actually describe each of these partner solutions in great detail. One of the partners I specifically wanted to call out is Reblaze. And Reblaze provides a web security solution. So it's in use at eBay and several of our other customers. And then, of course, it provides a WAF. It'll provide DDoS protection, anti-scraping. It'll provide fine-grained ACLs. One of the really interesting bits about Reblaze is this, that the architecture is actually fully powered by GCP, along with a lot of value-added intelligence that Reblaze brings to the solution. So I wanted to put this here so you can look at some of the foundational building blocks that come from GCP. Specifically, there are 5 services. So there's global load balancing, there is CDN, there is Claude Armour, there is BigQuery, and there's machine learning. Now, the global load balancing provides the edge infrastructure to absorb layer 3 and layer 4 DDoS attacks, and it also provides a point to do TLS termination. Now, the BigQuery is combined with machine learning, and then the kinds of things it will do is like traffic analysis in real time or application analysis. So this is where you want to profile legitimate users and their input and then make sure that it is something that you can feed back into the WAF. It'll do real-time biometric data analysis. So this is used to tell, for instance, bots apart from humans. And anytime once it detects something, it'll use the Claude Armour things such as Blacklists, so your signatures, and it'll delegate to Claude Armour wherever applicable. And then what the main thing it'll give you is essentially defense at the edge with this, and then your traffic or your bad traffic will never reach your VPC. And then you've got the Reblaze proxy instances, which will run all of the Reblaze value-added features that wouldn't get delegated to any of these systems. So the reason I wanted to show you this is because this shows what is possible using several of Google's technologies, especially Global LB, Claude Armour, other GCP services, to harden your own posture for your own services. And then, of course, you can complement each of these with solutions from our partners. So this was a whirlwind tour of Claude Armour, and I know we spoke about partners. One of the other things I wanted to talk about is our customers. And I think most of you are aware that we announced Target as our customer at this GCP Next. And with that, I'm delighted to invite Nick, our lead engineer for Target, to come and describe how they think about application security at Target. Nick.
Thank you. Thanks. All right. Thanks, Prajakta. Hi, so my name is Nick Jakes. I'm a lead engineer at Target on our cloud platform team. Just to give you a little context around who I am and what Target is. So Target's a pretty popular US retailer. We have over 1,800 stores in the US. We also have a good amount of distribution centers and several headquarters locations and a handful of data centers. I've been working on our cloud platform team for about 3 years now, and I want to provide a little context around timelines. Last year, the very, very beginning of 2017, we kind of embarked on this journey to migrate our workloads from a variety of cloud providers into GCP. We were able to do that prior to what we call peak season in 2017, so before fall comes around and Black Friday and all kinds of fun times around the holidays. And things went really well. So at the beginning of 2018, we thought, well, we've migrated the non-commerce parts of our site, so the parts of the site that will help you search or browse to find a product, or will display product images or reviews for you. What about the commerce part, the part that accepts credit card numbers, the part that lets you check out on the site, all kinds of things like that? And we thought, this is something we should do too. Our commerce environment was hosted in a dedicated colo facility, and so we thought it was time to modernize that. So at the beginning of 2018, around March, we embarked on that journey, and we're actually almost entirely done with it. So the vast part of Target.com, our mobile apps, and a good piece of our APIs as well have backends in Target or in GCP. So moving on, let's just kind of do a little overview of Target's architectural patterns. So the way that we've kind of built things out is that we basically have a CDN that fronts everything that we have on the web. So all of our traffic comes through the CDN. We apply a variety of useful features that the CDN provides, things like caching, web app firewalls, a massive amount of logging, and it also provides us with some defense tactics. So there we can do rate limiting, and we can also blacklist. So if we're seeing malicious traffic or if we're seeing large volumes of traffic, we can handle it there. The CDN is also useful for us because Target has a multi-cloud strategy. So we have a pretty big footprint in GCP, but we don't want to paint ourselves into the corner, so we want the ability to use other CSPs, or for example, if we have a trusted third-party provider for pieces of our site or certain functionality, we want to be able to direct that traffic to them as needed. And then finally, the third piece in this architecture is using the L7 load balancer. So I had a previous talk just a few hours ago where we went into a really deep dive about Target's architecture in GCP. Unfortunately, no one offers time travel as a service yet, so we can't go back, but it will be posted on YouTube. So if you want to really deep dive into Target's architecture and how we're using a lot of the network functionality of GCP, I would encourage you to check that out. And in there, you'll hear me just gush about all the amazing things that these load balancers do. We don't have to worry about pre-warming or scaling. We don't have to worry about regionalized load balancers and then doing geolocation at the edge and trying to figure out which load balancer is closest to the user, things like that. So it works really great for us. One of the amazing things about this that our teams really enjoy is the ability to scale based on requests per second coming in through the load balancer. So this is especially great if you have services that, for example, don't hit the CPU, so you can't really auto-scale based on CPU, but you know that a given instance can only handle so much traffic. So you can scale out horizontally the more requests that are coming into your load balancer. So let's move past that just a little bit, and now we're going to start talking about Claude Armour. So a really important thing for Target is that security is for everyone. It's for our team members, it's for our guests, it's for our team members who are our guests, it's for everyone that we interact with. So no matter what you're doing on Target.com or on the mobile apps or even using our APIs at api.target.com, security is really important. And this is where Claude Armour starts to come into play. So something was missing for us last year. Claude Armour wasn't generally available yet, and so we were kind of sitting there thinking, hey, these load balancers, these L7 load balancers are really great, but something's missing. We can't apply firewall rules to them. So that means that we don't have a way to only allow traffic from our CDN, for instance. We didn't really have a good method of ingress control. And like anything you put out on the internet, we began to see some kind of suspicious traffic. Obviously some of it's benign, it's people just kind of port knocking and seeing what's going on out there. Some of it, not so much. So here you can see just a quick snip from Stackdriver logs of traffic that is denied. A lot of attempts to try to get after PHP MyAdmin. I took a little time and I tried to catalog some of these, and now this isn't a definitive list or anything like this, but we obviously we saw quite a bit of different basically attempts to see if we had PHP MyAdmin or WebDAV or even Drupal installed. And so luckily, none of this is actually making it to our instances, and our instances don't run these pieces of applications, but this still isn't stuff that we want coming into our instances in the first place, right? We don't want people knocking on our door, seeing what's going on there. So this kind of moves into knowing and understanding traffic patterns. Obviously, there's a pretty wide spectrum. In some cases, in some industries, you can classify things as known good based on user interactions or source addresses or things like that. And in some cases, you can classify things as known bad, again, based on sources, or maybe you set a cookie or something like that. And for a lot of industries, there is a pretty wide gray unknown in the middle. In Target's case, luckily, we actually kind of fall over on the left-hand side. And the reason for that is we have a pretty limited list of criteria of what is good traffic to us. That is traffic coming from our CDN provider. That is traffic from our headquarters and data centers. It's traffic from other GCP projects, that is egressing and hitting api.target.com, for instance, and some trusted third parties. And then literally everything else we don't want. So we don't want the internet to come knocking. We don't want adventurous and crafty people trying to figure out what sales we're doing ahead of time, things like that. So this is where Claude Armour comes into play. So just to give you kind of a graphic view of this, this is kind of our overall architecture, right? So we have the ability for target guests and even people who aren't guests, or applications and computers who aren't guests, to access our services through the CDN edge. And that'll eventually make its way through and then come into our load balancers. Now, what we don't want to have happen is this other traffic kind of coming in from the side, right, and going through or bypassing the architecture that we've so carefully set up. So what's really useful in this particular instance is basically applying Claude Armour just at the load balancer there. And so when this traffic tries to come through again, Claude Armour just goes ahead and blocks that for us. So eventually, all this good traffic will come through, it'll hit the instances or our Kubernetes pods as intended, and those backends will never see that traffic that we just don't want coming through. So once we start talking about using Claude Armour, something that's really important is how you actually are going to use your policies. We actually have two different environments, as I mentioned earlier, our non-commerce environment and our commerce environment, and they're laid out a little bit differently. So our non-commerce environment, they're basically large monolithic projects that are multi-tenant, right? So we have many different applications running in these projects. The advantage in a single project is you can deploy one Claude Armour security policy and have that applied to all of your edge load balancers. So for your deployments that have many load balancers, this is really advantageous because you basically have centralized management of those security policies. Or if you have special requirements for a certain few load balancers, you can create one-off policies and apply those as well. If you have multiple projects, and this is our case in our commerce environment because we're using a feature called shared VPC. So in this type of configuration, what happens is we have multiple projects that contain just the applications that are intended for that particular project, and those are bound to their own individual subnets. Each project and each application in those projects has their own load balancers, and so we need to distribute those policies to each one of those service projects and then bind them to the load balancers. So that means things are a little more distributed, and it could be a little more difficult for you to manage. Luckily for us, things work pretty well. We have a centralized Terraform repository that contains all of our Claude Armour rules, and so we're able to deploy those across our suite of service projects pretty quickly. So just to kind of go through a blueprint of how we're doing things, in our non-commerce environment, we essentially have a single policy for all of our load balancers. That policy is effectively what I had just mentioned a few slides ago. We use Terraform to centrally manage that policy, and our application teams and our platform services teams use an open source tool called Spinnaker to create and manage their load balancers and also to deploy instances. We currently have an out-of-band process that goes through and attaches security policies to those load balancers created through Spinnaker. In our commerce environment, things are a little different. We're much more aggressive about the security policy there, or posture, obviously. So what we do is we have a policy per service project, and that'll attach to the load balancers in that given service project. Again, we use Terraform to manage these policies, and what we do is we actually abstract these policies from our tenants. So when our tenants use Terraform to create their load balancers, what's actually happening is there's a Terraform module under the hood that contains the Claude Armour policies, and it attaches it to the load balancer. So effectively, when we have one of our application teams create a load balancer through Terraform, the Claude Armour security policy and SSL policies are automatically applied like day one. So there is never a concern concern about a load balancer that wouldn't have these policies in place. So then just to kind of wrap things up there, with our load balancers, we take all of the Stackdriver logs, including all of the Claude Armour logs, and what we do is we use logging syncs to bring those back to our data center. Once they're in our data center, they go through a series of Kafka topics and subscriptions, and we ingest them into Target security infrastructure. So using that and looking at the type of traffic that's being blocked by Claude Armour, we can actually gain some insights into the type of traffic that's happening there and detect any possible attacks that someone may be launching. So if we rewind to our cloud journey in GCP, in fall 2017, Claude Armour was in its pretty early stages, but we wanted to have a defense mechanism should anything occur. So again, we were ingesting logs, and our security operations team was basically analyzing those and would tell us real time if we needed to take any sort of action. Our Claude Armour policy at the time was tactical blacklisting. So by that, what I mean is we had a rule set that basically was written to allow traffic and then left space in the middle that specifically denies particular traffic from particular sources, and then the default rule is allow. So in this way, we've given ourselves room to create deny rules, but we aren't going to stumble and accidentally blacklist one of our own addresses and cause big problems. One of the interesting pieces about this, because Claude Armour was in alpha, we had a few folks that were a little concerned at Target about how this would operate, would it scale? And our Google partners mentioned to us that this is used at the Google Edge for a lot of their products. And so that helped out, but there was still a little bit of concern. And so what we did is we actually applied this policy to all of our endpoints, and we didn't tell any of our application teams that we did that. And no one noticed a single thing, and everything went off without a hitch. So that was the kind of proof in the pudding for us that Claude Armour really does work. When we talk about how we're using Claude Armour today, we're shifting to a tactical whitelisting approach. So by that, what I mean is we have several rules in place that allow all of the authorized traffic that I mentioned earlier, traffic from our CDNs and data centers and things like that. And then right down at the bottom, we deny everything else. So in doing this, we really restrict that to those approved endpoints and through the architecture that we've so carefully set up with WAF and caching and all those great things at the front end. So we have these security policies deployed to almost all of our load balancers today, and we have just a few that we need to flip from preview mode to enable mode and block that traffic. So just another tip of the hat to the preview mode feature of Claude Armour. It's worked really great, and it's helped our application teams identify, in some cases, traffic from some of our systems that they didn't even know was hitting those endpoints. So it's been really great to help understand traffic there. Just to kind of go through quickly some lessons that we learned. Obviously, defense in depth is a thing. So adding Claude Armour isn't going to fix everyone's problems. You obviously need to take quite a few steps, but it does help in terms of filtering out some of the general traffic out there on the internet. We learned a very important architectural anti-pattern, and that is egress-ingress hairpins. So in our environments at GCP, we operate NATs. So most of our instances don't have external IP addresses. And in some cases, we reach out to parts of api.target.com that also live inside GCP. So we have this really nice kind of hairpin going on. And that can make it difficult to write a Claude Armour policy, especially if you're using items that auto-scale, and so you don't have predictable IP addresses. So that's something that we learned and something that might be good to avoid. Another item which we're working through right now is retroactively applying policy. It turns out if you start really restricted and then open things up a little bit, people are happy with that. If it turns out that if you start with things fairly open and then try to restrict that, sometimes people aren't a big fan of that. So starting secure by default and day one is a really great thing to do rather than trying to apply that over time. Finally, just as kind of a last few points here, organizational inertia can be hard to overcome. So this kind of again goes towards that retroactively applying policies point. So in every company, in every business, it's a little bit different, but sometimes can be a little tricky. And then there are a few scenarios that we've encountered that don't quite perfectly work for us, and we're still researching and trying to think of good solutions for. The biggest one for us is our users with split tunnel VPNs. So when you're working from the road or at home, your laptop will connect to Target and send traffic intended for Target's internal items or internal endpoints over the VPN. When you are going towards one of these public endpoints or one of these external endpoints, it will not go over the VPN. You won't have a target IP address, so you'll be blocked. So we're still working through some of those pieces and working to make that a little more predictable so that those users can still get their jobs done while they're working from home or elsewhere. So as we look towards the future and things that we're excited about, pretty much everything Prajakta just said. We're looking forward to a lot of things, and one of the most important pieces that we're looking forward to is the ability to automate policy enforcement. So if someone creates a load balancer in our non-commerce environment, that Forseti or perhaps another tool will pick that up immediately and attach a policy to it, so we don't have to worry about that. So with all that said, I'll turn it over to Sila, who's going to talk through quite a few interesting new pieces of Claude Armour. Thank you.
Hello, good afternoon. So far, Prajakta and Nick talked about protecting your cloud services using Claude Armour for known predicted attacks. You can use IP whitelist blacklist to block or allow some traffic, and you can also create geo-based access rules, geo-based access control rules, as well as SQL injection protection, as well as XSS protection. And taking one more step with Claude Armour, you could also create custom rules to prevent attacks from, let us say, known hackers or known attacks. But what about the protection for the kind of attacks that you did not anticipate? Globally, attack volumes are growing multiple times, and there's also an ever-increasing risk of high-volume attacks from large amount of small bots, as well as large, powerful hosts. So let's talk about some of the existing strategies your network security engineers will apply for protecting against these large attacks. Number one, you could increase your serving capacity to multiple times, but some of these attacks are so big, no reasonable increase in capacity will actually protect you against these attacks. And you could set up volume thresholds, but the problem with the volume thresholds is that when the attack is 4 times, 5 times bigger than your baseline volume, then you are allowing more attack traffic than the genuine traffic. And thirdly, you can set up analysis of the logs, as well as set up some statistical algorithms to run through the logs and come up with rules. But the problem is, by the time you react to this attack and come up with a rule that will isolate the attack traffic, your service may already experience downtime. What if a system exists such that some of these attacks can be detected automatically? And such a system can also detect and isolate the signatures of these attacks and come up with rules for you to block or throttle the traffic. And let me introduce Claude Armour AI. At Claude Armour, we are leveraging Google's innovation in deep learning as well as AI to come up with DDoS attack protection system that will not only detect, but will also provide protection in a timely manner. So you have seen the demo of Claude Armour a few minutes ago. Prajakta demonstrated to you how to write the rules and how you can apply them and protect your system. So today, as it is, Claude Armour will protect you against SQL injection as well as XSS threats. And you can write your own custom rules for some of the known attacks that you have faced in the past. And you can do IP whitelist blacklist for allowing or blocking the traffic. So let us say a hacker planned an attack on your system, and that falls into the existing spectrum of the rules that you've already created. Claude Armour will effectively block all this traffic. Your systems are healthy, and life is good, and no blaring pagers, right? Here comes a quickly ramping up bot attack. And the way this bot attack is structured is that it rotates through multiple user agents, a set of multiple user agents, as well as referrer URLs, and coming from 1 or 2 IP addresses. And this attack will quickly overwhelm your services if the volume is big. And your pagers will go off. And what would be the strategy of your network engineers here? They will have to go through the logs, and they will have to set up a statistical analysis to go sift through the logs, come up with isolating the signature. You may have spent any time between an hour to several hours, and your service will most probably experience some downtime. With Claude Armour AI, most of this toil can be avoided. Claude Armour leverages deep neural networks architectures to detect the attack and isolate the signature, as well as come up with rules for you to block the attack. In general, deep neural networks are very efficient. They allow us to predict these attacks with a lot more accuracy than regular machine learning algorithms. And they also allow us to fast train our attack models. And we will also be able to do distributed training of these attack models with large data sets. Once Claude Armour AI isolates the signature of the attack, it will also generate an alarm, and it will also create Claude Armour rule for you to apply and block or throttle the traffic. And once your network service engineers receive the alert for the ongoing attack, they can actually go to Claude Armour's attack console and check the signature, check the rule, and apply the rule. So from the time you apply the rule, it may take a few minutes for it to propagate, the policy to be propagated to all of the load balancers. But from the attack to the defense, it may take a few minutes from the time the attack ramps up. The advantages with this system is that you don't have to set up service thresholds. And it's basically, you don't have to worry about your periodic traffic variations. Claude Armour AI will train based on your traffic model and also the traffic patterns, and it will ignore any periodic patterns that your service may experience. For example, you may experience peaks in the morning and in the evening, and those will be ignored and will not be flagged as attacks. It's basically designed to reduce the toil. And as you see, Claude Armour AI is not one thing. It's basically the whole pipeline weaves through multiple machine learning algorithms and provide you the protection as well as quick detection of the attacks. Let's do a demo of Claude Armour AI. Here is Claude Armour AI's console, and this is the traffic analysis console. As you see here, your service is fine. You have a baseline around 5,000 QPS, and the top part shows you the attack traffic. And currently, there are no attacks, so everything is good. And on the top, as you see here, the console shows you the total cumulative request as well as the allowed request, and it shows the blocked and predicted request. And here is your defense console. So far, systems are normal. Everything is good. Now let's initiate an attack. So we've talked about the attack previously. It basically weaves through a lot of user agents as well as referral URLs. And let's launch the attack on the service. And let's see what happens and if Claude Armour AI will detect the attack or not. So once you launch the attack, let's go back to our traffic analysis tool. And as you see here, you see towards the end, there is a peak in the volume, but Claude Armour AI hasn't detected yet. So you may take any time between 30 seconds to 2 minutes for Claude Armour AI to pick up that there is an attack going. So as you see here, the attack volume is ramping up, and it's going to 6,500 QPS or so, and slowly ramping up to 9,000 and 14,000. And there you see Claude Armour detecting an attack here. It's not only detecting that there is an attack, but it also gives you a classification of what part of your traffic is attack and what is actually a genuine traffic. And as you see on the top, here on the top, you will see the predicted attacks. Now we can click on the spike over on the predicted attacks, and we can actually see what is the characteristics of this attack. As you see here, so you have the attack coming from through IP addresses. 50% of the attack is distributed to one IP and the other. And you have referral values basically taking up some of the volume. And it's not only the referral values. One of the primary characteristic of this attack is also user agents. So it will assign what kind of volume is coming from each one of these. So the advantage of Claude Armour AI is not just detecting the peak, right? Any statistical algorithm will be able to detect the peak. But here, you are able to detect that this is an attack, and you are able to characterize the attack and come up with a rule. And here is your console, the defense console. You can see that the service is under attack. And also the attack signature. It shows you what are the prominent features of this attack. And here we have the remote host, user agent, and the referrer URLs. And it also suggests a rule. So you've pretty much reduced your attack response time from hours to minutes here. And then once you see the rule, you review the rule, you can go ahead and click on the rule to apply. And it may take a few minutes for the load balancers to apply the policy. So that concludes our Claude Armour AI demo. So back in September 2016, Evernote announced that they are migrating from their on-prem to Google Cloud. And post the completion, they have given us a really big endorsement saying that they not only matched the on-prem security with GCP, but they were able to surpass the security levels they experienced at on-prem. So this is a great endorsement for us. And it's not only Evernote, but there are several other customers using Claude Armour to secure their deployments. And our goal today here is to share with you some of those awesome customer experiences, as well as demonstrate that GCP is a secure first network. We are investing a lot into making your services secure. And with Claude Armour and Claude Armour AI, you can not only secure your GCP services, but also reduce the toil in protecting your services. And you are basically, by using Claude Armour AI, you are outsmarting your attackers.